Hi, my name is David, and I'm going to walk you through how I solved the CSWA practice problem 7.4. I gotta say, when I first looked at this problem, I had no idea what I was looking at. I didn't know if these were hollowed out cylinders or what was going on. But then the closer I looked at it, the more I realized what was going on. If you see these little curves right here and here, that sort of, if you follow them out, that indicates it's going to be circular. These little parts are going to be circular in this direction. And then from this little snapshot here, you can also see that it's rounded above as well. So basically from the different directions that we're seeing, these are spheres that then have spheres cut out of them. So that's what we're going to do is first make a bunch of spheres and then make straight circle cuts in the middle and then on the outside as well to make this like annulus shape. All right, so the first task is going to be to actually make these little connecting parts, which when you first look at those, you think like, how are you going to make those connecting parts? But what we're going to do is just make a cylinder that goes all the way to the middle, and then we'll make the spheres, and then we'll make the cutouts of the spheres, and then finally cut from the top. So that's going to be our game plan. All right, so we'll start with the top plane, make a big circle, and it goes out to a diameter of, 14.5 plus 2 times 2. So if you look at this original picture here, it goes all the way out to a radius of 14.5, but then plus the thickness of 2. So the diameter will be all that times 2. Okay, and then we can do our extrusion. I've got Control-E set for my extrusion shortcut. We can right-click and do a mid-plane extrusion, and it looks like the thickness is going to be 1. All right. So that's going to take care of these little connecting parts. And when we do the cutaway, the connecting parts will remain there when we cut out the center. All right, so now we want to make these spheres, and we're going to focus on this first sphere here. We'll make the whole sphere by taking part of it. So I'll just use this picture here. So we'll create an arc, and then we will draw a line like this. Actually, I probably don't want to draw it in this picture because it's going to be just as easy to make the sphere from the top plane as it is from any other plane. So maybe convenient to just use the top plane, because when you create a sphere, it doesn't really matter where you make this profile, this half profile. Anywhere you make it, as long as you revolve about the line right here, it's going to make a sphere. So I'm going to use the top plane actually, rather than another plane like this. And so I'm going to create this contour here and revolve it about this line to create the sphere. All right, here we go. In the top plane, first I'll create a center line that just goes all the way down to have something to draw points off of and make sure that it's locked into place, vertical. Well, not locked in, but at least vertical. And then I'm going to create an arc. So 2 points on the center line, and then the arc is going to be a radius of 4. If you take a look, the cutout has a radius of 3, and then the thickness here is 1, so that's a radius of 4 all the way out to the big sphere, like the sphere that we're about to create. Okay. Now we want to make sure that it's actually going to be a sphere, so we have to make sure that the center of the arc is coincident to this center line. So I'm going to use Alt-D for coincident relation. And then we want to make sure that it's in the correct place. And here's where I made an assumption. All right, so I'm assuming that the center of the sphere is halfway through the annulus. So this annulus shape, when we look at it, it has a thickness of 2. So I'm going to assume that it's 1 in from the outside and the inside of the annulus. So that means that if I went from the origin out to the center of that sphere, it's going to be 14.5 plus 1, so 15.5. So that means that from this origin to the center of this arc, which will become the center of the sphere, it's going to be the 14.5 plus the 1. Okay, now the arc is locked into place. At this point, we can actually just go ahead and do our revolve. It's going to complain because this is an open sketch, but it'll close it automatically when you do a revolve like this. So we can click yes and hit enter, and there we go. We've got our sphere. All right. Now let's go ahead and do the cutout. We'll again use the top plane. And one of the things, I can't believe it took me this long to figure this out, but one of the things is when you use a sketch inside of a feature, it automatically hides the sketch. So if you want to show the sketch again, you can just click on the sketch and then click on the eye, and now all of those parts of the sketch are shown, and you can reference them. That was mind-blowing for me, so I hope it's mind-blowing for you too. All right, so we're going to go ahead and, because now we have access to the center of this arc right here, so we can lock in the cutout arc that we're going to make to that center. Okay, so let's make that cutout. And not to mention, we can use this center line as well. So, I'm just going to draw it up here and go ahead and make the radius 3. Then I'm going to lock this one into the center of this arc, make them coincident, and there we go. Now one of the things I noticed is that when you try to do a revolved cut, it doesn't automatically close off the contour. It doesn't make it a closed contour. It just kind of complains. So I'm going to go ahead and close off the contour manually, and then do the revolved cut right here. About the axis of revolution, we can use this one. Hit enter. Now, it doesn't look like it actually did anything, but if we go to the top plane and then section view, so that we're cutting off to look at it, we can see that indeed there was a cut that was made inside the sphere. It just kind of covered it up because the whole sphere is covering it up. So that's looking good. Can escape out of section view. So at this point, we want to we can go ahead and hide this sketch again. We want to make a copy of this going all the way around in a circular pattern. So we can select the revolve that made the sphere, hold down Shift or Control, and then select the cutout inside, and then go to circular pattern. Now it's going to want a direction, so we want to go around in a circle like this, and we want 8 of them. I already have 8 because I did this problem just a second ago, but you want to make sure you change that so it gets 8 of them and they're equally spaced, and so you can hit enter, and there we go. We've got these 8. So now last thing to do is from the top plane, go ahead and cut out the inside, then cut out the outside. So we'll do that with a couple of circles. All right, and then in terms of the radius of the circles, or the diameter of the circle, it's going to be for the inner one 14.5 and then times 2. Okay, so 14.5, let's see, times 2. Great, got that one. We'll go ahead and do this cut. If you're not already selected into through all, you can right click and do through all both directions. But I am, so make the cut. You can see it's starting to look pretty nice. Then top plane again. We'll make a circle out to the end, and for this one it's going to be the 14.5 plus the 2 thickness of the annulus times 2. So that ends up being 33. All right, and so then we can do the cut. Now in this case we don't want to cut inside that circle. We want to flip the side of the cut so it's cutting outside the circle. So that'll shave off all these parts outside. Hit enter, and it's looking pretty good. Let's check the mass. We've got 421 it would round to. And 421 cubic millimeters is the correct answer. I hope this video was helpful. For more CSWA practice problem solutions, you can check out Design with Roozbe. Take care and keep studying.